Hi students, this is lesson 89. I have to apologize. I recorded this lesson last week for you and posted it, probably 4 or 5 days ago, and I just went back to check on it and the upload failed. So you never got lesson 89 and I'm really sorry about that. It's a busy lesson, so let me introduce you to it. There are two distinct pieces to it. And so I'm going to handle it. I think I'm even going to do separate videos because they're so different. The first one that we're going to tackle in this one is conjunctions and disjunctions. They're related. They're not hard, but they go together. Then in a second video, there's a third topic, products of chords and secants, and that is geometry related. So, look for a second video on part C. This is parts A and B. So let me start with part A. Conjunctions. I'm on page 368. And the idea here, the word conjunction has the word con as a prefix, and as you know, with a conversation or a composition, the prefix con means two things coming together. And so you'll see that when we look at our examples, we're going to have two very simple kinds of graphing situations, and they will be coming together. I'm copying down example 89.1, and it says to graph this and, very important word, x minus 2 is less than 1. Okay? And for this problem, we know I'm skipping space here for a reason. You'll see in just a second. Okay, so what I've done is I've copied down the problem in kind of a weird format. You'll see that what we have are two inequalities that we're supposed to graph. I left room because as soon as I saw these, I realized they're going to need some algebra to get them into a graphable format, so I skipped this space so that we would have a little bit of room to work. Then I also wrote down the domain is the integers. Wow, those are really messy brackets. And what that reminds us is that when we get around to graphing, we're going to be using dots rather than a number line. Remember, or the straight line. We use the line when we've got a domain of the reals, but for integers we use dots. So I always put those dots there to remind me that that's what I'm going to be doing. So the first step I want to show you is, and you've done this before many times, we're simply going to algebraically straighten these two inequalities up so they're graphable. I'll start with this one. I'm going to start by moving this 3 to the opposite side, and I'll have minus x, that cancels, is less than or equal to positive 1. I'm going to write down the 1 so I don't get confused. And notice when we added 3, that doesn't do anything to the inequality sign, but now we're going to do that unthinkable thing. We have to get rid of this minus sign, so we're going to multiply both sides by minus 1. I'll put brackets around everything so it's clear. Now this becomes the positive x that we want, but when we multiply by minus 1, we have to flip our sign. We don't change the sign at all, we simply reverse it. And then negative 1, or positive 1 times negative 1 will be negative 1. All right, so this is our first graphable piece. And now let's just clean up this one. We have to add 2 to both sides. X is less than 3, right? Now, what you'll see is that when we go to graph these, we're going to put them both on the same number line. I'm going to put a 3 here, and I'm going to put a minus 1 down here. I'm going to count everything in between. Minus 1, let's see, it's just 0, 1, 2, and 3. That kind of worked out fairly neatly. Okay, so I'm going to graph the first one first. X is greater than or equal to minus 1. So that's going to start us with these points, right? But at the same time, I have to graph what is also true for this one. We want the place on the number line where both of these things are true because it's a conjunction. And the word that we're focusing on is and. So we want the solution that makes both of these true. This one says not 3, but 2 and 1. So this is our final solution. Notice that it includes the points that are greater than or equal to -1 and less than 3. Okay? Makes sense? A little messy, but you can see it. In contrast, oh, stop, pause, my brain. You guys go ahead and work example 89.2. That's for you to do right now. Go ahead and pause me and come back after you get a chance to practice that. Okay, you're back. Part B, here's our conjunctions off our main list. Disjunctions. So messy, my handwriting, when I'm writing on the floor. Sorry about that. Disjunctions focus on the word dis, like disagree or disapprove. They are they're a situation where the two things are not going to agree. And so you'll see that the graph on these will look a little bit differently. So let me do example 89.3. It looks like this. Graph. I'll slide my paper up just a little here. Last night there was a lizard on the wall right by where I'm working, and I'm super freaked out that it's kind of come out again. They're not that big. They're maybe like that long, but they just run all over the walls, and it really freaks me out. So forgive me. Okay, graph. Minus x is greater than or equal to 3, or, there's our word, or minus x is less than -1. All right? So that's what we're going to be graphing. Our domain this time equals the reals. So that tells me it's not dots, it's going to be an arrow, one way or the other. I don't know which way yet, but it tells me that we're going to be using the arrow line rather than just the dots like we did up there. All right, so same process. We need to straighten up our the algebra of our equations. This one, we've got a negative problem, so here we go, people. Let's multiply by -1. So now we have x, this flips, is less than or equal to -3. So that's formatted properly. Or, oh, we have to do the same thing here, don't we? Multiply by -1. Don't forget to flip. X is greater than +1. All right? I'm going to squeeze in my number line so you can see it. It'll be a little messy, but I don't want to take you away from the calculations here in order to graph it. There's our number line. We'll need -3 down here. That's -3. I circled it. We'll need +1 up here. Let's see, -2, -1, 0. Not quite perfect. And then I'll add a few on the bigger side of these. Okay, so what we're going to graph now is both of these solutions. There isn't going to be overlap. That's what the word dis tells us. It tells us, people, there isn't going to be any overlap. Just graph them and don't worry about it. So we're graphing the reals. We've got -3. I color in the dot because it includes the equals, and then I graph all the points in this direction are going to satisfy this equation. This one, I need a circle at 1, and I need an arrow going this way. So now you can see what always happens with these two types of inequalities. With a conjunction, we're looking for meeting in the middle. With disjunction, we're having a disagreement, and the two graphable solutions are going in opposite directions. It's always true of conjunctions and disjunctions. Go ahead and try example 89.4, and then that will wrap us up for this segment of the video. I want to record section C on a different video just because it's easier to upload. So I will see you in the next video for part C. Good luck with this.